So in the previous video, I gave you definition of composite of prime factors, and we did an example where we expressed it off as a product of its prime factors. Today we are going to look at a more larger number. For example, if you are asked to express 294 is a product of its prime factors. We are going to use the tree method, where we are going to put the prime factor that's going to be dividing this number, and the remainder is going to be put on this side. So if we divide 294 with the smallest number, prime factor 2, we get 147. Again, we're going to put the branches here and here, and we're going to divide with the smallest possible prime factor. 2 can no longer enter into this number, 3 cannot enter into this number, 5 cannot enter into this number. Remember, prime factors 2, 3, 5, 7, and so on. So here the smallest prime factor that can enter into this number is 7. So we're going to put 7 here. 7 into this, we're going to get 2, 1. We get 21. Another smallest prime factor that can enter into this number, 7 again. We put our branches, do not forget. 7. And how much does 7 enter into this number? 3. So 3 is also a prime factor. So we take these, our factors, and the last remainder. Then we write 294 is equals to, we multiply 2 multiplied by 7 multiplied by 7 multiplied by 3. We have 2 7s here. You can also write it as 2 to the power 1 multiplied by 7 to the power 2 multiplied by 3 to the power 1. That is our answer there. So we are going to move on to the next example. You have to express 784 as a product of its prime factor. 784 is a product of its prime factors. Again, we put our branches, the first branch and the next branch. So we're going to take the smallest possible prime factor. Remember, these are our prime factors. Smallest possible prime factor, 2. 2 into this number, we're going to get 3. Remainder 1 here, 9, then 2. Then we put our branches again here, 2. 2 into 392, we're going to get 1. Remainder 1 here, 1. Remainder 1 here, and you're going to get 9. Remainder 1 and 6. So again, we take 2. 2 into 19, you get 9, remainder 1. 2 into 16, you get 98. So again, you can divide by 2. You put your branches, and you divide by 2. 2 into that, you're going to get 4, remainder 1, then 9. So if you look at this, 3 does not enter into 49. 5 does not enter into 49. But 7 enters into 49. You put your branches, 7, remainder 7. So we write our number, 784 is equals to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 7. So how many 2's do we have? 1, 2, 3, 4. So we're going to have 2 to the power 4 multiplied by 7 to the power 1. This is the product of its prime factors.